This is the leisure centre building. The brown colour here is the proposed dredge level. The green is an environmental berm. The red is the sheet pile. It says 26700. The blue and cyan are seeking pile wall. The yellow is a guide wall for the seeking piles, and the grey is an RC wall sitting on top of the guide wall, which is at existing ground level. So the seeking pile wall is needed here because the loading of the building is extremely close to the flood wall, and as the flood wall moves away from the building, it can transition back to a sheet pile wall. You can see the ramped arrangements here provide pedestrian access from the leisure centre up this ramp, and then you can go along the top of the wall to tie into the old bridge deck, or you can come down this ramp on the river side of the flood wall where you can get access to the river. So you can continue on under the dry arch, or you can come down a series of steps and turn and walk back along the environmental berm. So this ramp is built on top of an L-shaped wall, which is to the river side of the flood wall. There's an existing foul sewer in the river bank here. It's proposed to be diverted to the land side of the building, coming down here through the wall and down underneath the ramp and tying into an existing manhole underneath the dry arch. So there's pedestrian access from the car park is maintained down along the river bank on the land side down to these existing buildings. So no change to the topography on the land side of the proposed wall at that location. On the downstream side then you can see the existing sewer here coming from the existing manhole underneath the dry arch and tying into the existing pumping station here, where it's lifted up to tie into the stores at street level on Shannon Quay. You can see a proposed gabion basket wall here tying the pier of the existing bridge into the existing wall here on Shannon Quay. So this existing wall is proposed to be reduced in height by about a metre so that you can walk from the existing ground out onto the top of the old quay wall in Shannon Quay. So this is the old quay wall here, and the existing ground on both sides is quite similar, but the wall needs to be reduced in height so that you can walk out from this location out onto the top of the old quay wall. So fishermen's access will be provided by this box out creates an area for a couple of steps whereby you can come in from street level, up a couple of steps, over the top of the wall, down a series of steps to land on the existing ground where you can walk out along the top of the existing quay wall, or you can turn back and walk underneath the dry arch. I think the sheet pile wall here, the AZ26700, can start on the downstream side of the pumping station. We had proposed to step out around the pumping station, step back in and tie into the old bridge. We don't know a tremendous amount about these existing walls. They may contain sheet pile already, they may be reinforced concrete, they're stone clad at the moment. We should do a trial pit at the base of these walls to try and find out a bit more about them. Either way, I think we can grout the ground here or something to create a barrier to seepage, but we should start the sheet pile wall on the downstream side of the pumping station. So the environmental berm continues on the river side of the old wall. This old wall does not extend down beyond 0 meters above sea level. The dredge level is minus 1.25, and so this environmental berm is structural. Similar on the Abbey Quay side, we have an AZ26700 sheet pile. The sheet pile extends in this model fully up to flood protection level, although it will in reality contain extensive glazing along both sides, along both quays, but just to keep it simple here, I've extended the sheet pile up to full flood protection level. This is the existing quay wall on Abbey Quay and the existing ground in yellow behind it, so to be retained. And again, we need a structural berm here because the wall doesn't extend beyond 0 and the dredge level is minus 1.25, so this green wedge here is structural, and that continues down along the full length of the quays on both sides. So you can see here just in yellow a snippet taken from the survey of the current river bed, and you see there the proposed environmental berm is very similar in height to the existing river bed, so the amount of old quay wall that remains on show is very similar to what you see at the moment. As we move down along then towards Seamus Rafter Bridge, you see the line of the sheep piles can be kept to the riverside of the existing abutment on Shannon Quay side. So no interface with the abutment there. It can remain in the ground. And the sheep pile wall is to the riverside of it. We just remove the deck and the piers in the river. And on the Abbey Quay side then, the sheep pile wall can butt up against the abutment on the upstream and the downstream side. An RC wall can connect the two above ground or above the abutment, and we can grout the ground underneath to create a cut off to seepage. On the riverside then, the environmental berm almost completely hides the abutment. You can just see the red sticking through there. I'm sure the environmental berm can be tweaked locally there to hide that. Looking down along the prom then, so we have shallow dolerite here at -5 meters. With the road is raised on the land side, creating an additional loading into the wall. So an environmental berm is required here. So this is at plus 1.5 and it slopes out at 1 and 1.5, and this berm is required here to support the wall. If this berm was not here, we would need anchors or something more complex. So this keeps it nice and simple. On the Wexford Road side then, we have an existing wall here in grey, and we have the proposed flood wall sitting on top of it. So rock is very shallow at this point. We have this L-shaped concrete wall sitting on rock, keyed into the rock here for sliding. So structurally, we've not done a calculation. We don't know a tremendous amount about this wall. We should perhaps find out some more in our additional GI, but we know the line of it. That's about it. So this environmental berm, although we haven't done a calc to say that it's necessary here, I believe there's benefit in having it here. Structurally, we're putting quite a loading into an existing wall that we don't know a tremendous amount about, and as well as the structural need, aesthetically, I think it's nice to have symmetry there in the two environmental berms being equal. So I have the same environmental berm on both sides there. I think we need advice from the client there as to whether that's acceptable or not. The cross-sectional area of these berms combined is 10 meters squared, which is about 5% of the overall hydraulic envelope between the two walls and the proposed dredge level. So I think we need advice there from the client as to whether that's acceptable or not, or we need some further hydraulic modelling to confirm. As we move down along the prom then, the rock becomes deeper, and from about halfway down where the existing slipway is, we can reduce the size of the berm from there down. So we can taper the larger berm to the smaller berm and continue on with the smaller berm on the prom side, and for symmetry we should do the same on the other side as well. So